Destructuring just means you unpack values from an object into variables. Imagine we have a user object with a lot of properties, and you want to extract the first name and last name, and then put each one into its own const variable. Normally, you would write it like this: const first name equals user.firstname. And because that gets very repetitive, we can write the same thing in one line of code instead. Like this: const, and then in curly braces, first name, comma, last name equals user. This will do the exact same thing, just shorter. And the best part is, if you ever need more values from the user object, you can just add them here, separated by commas. So this creates a new variable and extracts the value from the object property that has the same name. This means these variable names have to match exactly the property names. Now this is how it would look like in a typical React component. I receive the props object, and then I destructure the title, price, and isActive. Later, I can use these variables inside this React component. The same concept applies to arrays. For example, the useState hook in React returns an array. To create our state variables, we use array destructuring. It works just like object destructuring, but with square brackets instead of curly braces. But this part already has more to do with React than with destructuring itself. Next up, the spread operator. You recognize it by the 3 dots. The spread operator can copy all entries of an array or object. You can use it to create a new object based on the values of another one. And in React, we use that all the time, mostly when working with states and props. But how does it work in JavaScript? Imagine I have a simple array, and if I want to add something to this array, I can use the push method. Pretty simple. But what if I want to create a new array based on this array, and I want to add a new element to it without modifying the original array? Using push would not work here, because we are still performing that push on the original array. So if we take a look at the console, we can see how both arrays now contain 3 items, and this is not good. I want to keep the original array unchanged, and at the same time use it as the basis for my new array. The solution is the spread operator, because it can copy all entries of an object or array. You write 3 dots, followed by the array you want to copy, and then I can simply add new values separated by commas. Now in the console we can see that the original array remains unchanged. It only contains 2 items, but the other one contains the new items. And of course, the same idea applies to objects. I use the spread operator to copy all properties and values from one object into another. Now let's get to the most important concept yet: array methods. React relies heavily on a few array methods. The most important one is map, because you can use this to turn data into UI. Imagine you have a products array. Each product has an ID, a title, and a price. Now you want to display that list on the page. With map, you can loop over every product. And then for each one, you return a piece of UI. This pattern is used all the time in React. There are also a few other array methods that come up a lot. Filter can remove items. For example, only show products under 20 euros. Find picks one item, like open the product with this ID, and includes checks simple conditions, like is this category selected. So these are definitely worth learning. The ternary operator lets you handle if statements in one line of code. Instead of writing a full if statement, you write a condition, then a question mark and 2 outcomes, one for true, then a colon, and then one for false. In React, we use this to decide what should be rendered. For example, you might show a buy button only when the product is in stock. So you ask in stock question mark and then return the button. Else, which is the colon, you return a message like sold out. If this syntax looks strange at first, that is completely normal. But once you get used to it, you will use it all the time. Closely related to that is the logical AND operator. This one is so simple. If the expression on the left side is true, React will render what is on the right side. If it is false, React renders nothing. For example, when the product is on sale, you render a span which says sale. React takes advantage of this behavior to conditionally render elements. Now let's talk about optional chaining and nullish coalescing. These 2 features make your code much safer. Optional chaining lets you access a value only if it exists. So imagine you want to show a user's first name in a heading. Without optional chaining, your app would crash if the user does not exist yet. Loading some user data could take some time. So you simply add a question mark after the user. It's basically asking if the user exists. It only then accesses the .firstname. Nullish coalescing uses 2 question marks, and it is meant for precise fallback values. It only kicks in when the value is null or undefined, and nothing else. In this example, guest is only used when first name is missing. So if first name is an empty string or a value like 0, it will not be replaced because it is still there. But if it is null or undefined, then we know that the value doesn't exist. So we show the fallback value on the other side of the double question mark. Let's learn about modules. React apps are built into many small files. For example, you can have a file called button.jsx. Here you define a simple button component. But to use this component in other files, you have to export it. So you write export default and then define the component. Now in the app.jsx file, you can write import button from and then the path to that file. Now, having imported the button will allow me to use it anywhere in this file. For example, right here below my h1 heading. So the idea is simple. I can define some JavaScript logic in one file, and by exporting and importing it, I can use it in another file as well. Finally, let's talk about asynchronous JavaScript. In React, we often work with data that doesn't exist yet. APIs, server responses, loading states. And for all of these things, you need promises. A promise can be pending, fulfilled, or rejected, because there's some uncertainty if the thing we're doing asynchronously will be successful or not. If the promise is successfully resolved, you can chain a then block to work with the data inside that then. But if the promise returns an error, then you would use the code in the catch block to handle the rejected promise. But there's also async await and many more advanced behaviors in asynchronous JavaScript.